Hi Math 095. Today we're going to be talking about the properties that will help us simplify algebraic expressions like the commutative property, the associative property, and the distributive property. We're also going to look at like terms and evaluate more expressions involving grouping symbols. So first we're going to look at the properties. These properties, the associative property, the commutative property, are all things most of you have probably heard. We're going to run through them quickly and then look at some examples of them. The commutative property works for both addition and multiplication. This is the property that tells us the order that we add or multiply numbers in does not matter. So a plus b and b plus a, they will be equal to the same value. If we look at 2 plus 3, does that give us the same thing as 3 plus 2? It does. Both of them have a sum of 5. Same thing with multiplication. 2 times 3 is going to be equivalent to 3 times 2. They both give us a product of 6. That's the commutative property. The associative property says if you have at least 3 numbers, A, B, and C, then the order of which ones you group together to add first or multiply first does not matter. So if I add A plus B first and then add C, I'm going to get the same thing if I add B plus C and then go back and add A. So as an example, let's do 2 plus 3 plus 4. Will that be the same as 2 plus the sum of 3 plus 4? So over here we get 5 plus 4, which gives us 9. Over here we get 7 plus 2, which still gives us 9. Same thing will happen with multiplication. If I have 3 numbers that are being multiplied, I can multiply the first 2 first and then multiply that product by C, or I could multiply B times C first, go back and multiply that by A. As long as A, B, and C are in the same order, those will come out to be the exact same products. The distributive property is the one you probably might remember the most because you use it a lot. If you have A, B, and C, and one of those numbers is being multiplied by a sum, or it could be a difference as well, then that number on the outside has to multiply by both values on the inside. Even if there's more than 2 here, you have to multiply this number on the outside that's being multiplied by the product by all of it. Doesn't matter if that number is on the front or the back. Okay, it would look like this: 2 times x plus 3. 2 multiplies by x to give us 2x, and 2 multiplies by 3 to give us positive 6. So let's use the distributive property to simplify these expressions. The first one, the 4 is being multiplied by the difference of 3 minus 9x. So since we can't actually subtract these two because they're not like terms, which we'll talk about in a little bit, we have to multiply. When we multiply using the distributive property, we will always eliminate the parentheses. So 4 times 3 is 12. 4 times negative 9x is negative 36x. You can leave it like that. My math lab may ask you to put the variable term first. Make sure you always take the sign with it. So since there's a minus in front of the 36x, we look at it as negative 36x. Since that 12 is positive, we put a plus sign between those two terms. B, we've got a negative times the difference of negative 60 minus 7. Anytime you've got a negative sign out in front of a sum or difference, that means there's a negative 1 there that needs to distribute. So a negative times a negative is going to give us a positive 6D. Negative times negative 7 gives us positive 7. Let me extend this page a little bit. Part C, the number 8 is on the back. Doesn't change anything, and in fact the order that you multiply in doesn't matter. So if you want your variable term to go first, 8 can multiply by 7y. That gives you positive 56y. 8 can multiply by 6, and that gives us positive 48. Last example on this page, negative 5 is multiplying by a 3-term sum or difference, so the only difference is we have to multiply 3 times. Negative 5 times a squared is negative 5a squared. Negative 5 times positive 8a is negative 40a. And negative 5 times negative 6 is positive 30. So that's using the distributive property. Something I think you'll be okay at. Like terms and unlike terms are things you'll deal with a lot, not only in this class, but in your other math classes. If 2 terms or 3 terms or however many terms you're working with are like terms, that tells you you are allowed to do certain things with them. 2 terms are like terms if their variables are the exact same, including their exponents. So these are some examples of like terms. 8x and 3x are like terms because their variable parts are exactly the same. If I make this 7x cubed and you want them to be like terms, this would have to be 10x cubed. Okay, the numbers in front of the variables are called coefficients, and those can be different. They can be anything, but the variable parts have to be exactly the same in order for them to be like terms. If terms are like terms, that means you are allowed to add and subtract. If they are not like terms, they have different variable parts, then you can't add or subtract. You have to leave the 2 terms separate. You can, however, multiply and divide terms even if they are not like. So using those like term rules, let's simplify. All you have to do, it's like taking a basket of apples on the left and a basket of apples on the right and putting all of those apples into one basket in the middle. That's what like terms is like. So since these both have b parts, all we have to do is combine their coefficients into one number. So whatever those numbers are, you always add them. So -7 plus 4 gives us -3b. I like to look at that as you have 7 negatives and you've got 4 positives. We know 1 positive and 1 negative will always cancel each other out. So our answer is 3 negative b's left over. Okay. 8c minus 9c, remember you can add the opposite. That means you are adding 8 and -9, which gives us -1c. Usually when 1 is our coefficient, even if it's negative, you won't see it. You'll just put the negative sign in front of it. 9x plus -6x, we've got 9 positives and 6 negatives. So 6 of those positives will cancel out with 6 of those negatives and leave us with positive 3x. Again, we're going to add the opposite here, so that means we're adding -7 and -4y, which gives us -11y. If you need to draw this diagram for all of these, do it. Do whatever you have to do to help you figure out the problem. How do properties of multiplication help simplify variable expressions? The associative property helps you simplify when you are multiplying 3 or more factors. Commutative property is used to change the order in which factors are multiplied. Remember, a times b is the same thing as b times a. Multiplication property of 1 says that the product of a term and 1 is the original term. So it looks like this: a times 1 will always equal a. 100 times 1 will always equal 100. X times 1 will always equal x. The number 1 is what we call the identity for multiplication because it doesn't change what we are starting with. The last property is what we call the inverse property of multiplication. That says the product, meaning multiplication, of a term and its reciprocal. Now a reciprocal means the opposite fraction of any number or term. When you multiply these two together, okay, you can cross cancel the a's, cross cancel the b's, you're left with 1 over 1, which equals 1. Okay, what that means is that any number, whether it's a fraction or not, multiplied by its reciprocal or the opposite flipped over number will always give you 1. We multiply across, we get 2 over 2, which we know simplifies to 1. So let's simplify these terms. -6 times 4y squared. Remember I said that it doesn't matter if they're unlike terms, you can still always multiply. So since this one has a y squared, it means y squared will just be in our answer, and you multiply the coefficients. -6 times 4 is -24 y squared. -1/9 times negative 9d. I'm going to rewrite this a little bit. Remember, we need to apply that negative to either the top or the bottom. I always apply it to the top. These parentheses mean we are multiplying, and any whole number can be rewritten as a fraction, so I'm going to write that as negative 9 over 1 and leave that d behind that fraction. It's the same thing. So when we multiply our fractions, on the top we get positive 9, on the bottom we get positive 9, we have our d here, and 9 over 9 means 1d, or just d. That would be using the reciprocal. 5 is, or C is just like A. We have an A term here multiplied by a number, so an A will be in our term product. 5 times negative 6 is negative 30. Finally, this cut off a little bit. When I copied, that should be a 4, and this should be a 3. So we've got 3/4 times 4 over 3. Again, I'm going to take that x out of the numerator and put it behind it. It doesn't change its value. Multiply across, and I get 12 over 12x, which equals 1x, which is just x. Go a little bit further and start using more than one property. We've got the distributive property here. Remember, we've got a negative in front of a set of parentheses. That means a negative 1 needs to be distributed. Then we're going to have to look at our like terms. We've got C terms and D terms. So when we distribute, we get negative 6C. A negative times a negative will give us a positive 6D. Second distributive property, a negative 1 times negative C is positive C. And negative 1 times negative 3D is positive 3D. Then we've got to combine our like terms. So my C's I'm going to put first, so I have negative 6C and positive 1C. Remember, when there's no coefficient, you think of it as a 1. So I've got 6 negatives, 1 positive. That will leave me with 5 negative C's left over. And then I've got 6D plus 3D. That gives me 9D terms. Example F involves not only the distributive property, but also our order of operations. We've got grouping symbols here with the brackets, so we know we have to work from the inside out. On the inside, we've got 3w minus 5 times w plus 6. So we have to do the distributive property here. So everything in front stays the same. 9w minus 4 times 3w. Negative 5 times w is negative 5w. Negative 5 times 6 is negative 30. Notice I dropped the parentheses. That's what the distributive property is for. Continue with our order of operations. Inside my grouping symbols, we're going to combine like terms. So I have 9w minus 4. That's going to multiply by negative 2w minus 30. If you want to add the opposite to help you understand why we get negative 2, feel free. 9w minus 4 times negative 2w minus 30. We can use the distributive property here. So 9w will add, because of a negative times a negative, 8w, and we will add 120. We've gotten rid of all grouping symbols by using the distributive property. Now I'm going to go ahead and combine my w terms. 9w's and 8w's gives me 17w's plus 120. Now this last one here, again, we've got grouping symbols. Inside the grouping symbols, we've got the distributive property by 2 and the distributive property by negative 1. So negative 3 will eventually multiply by 6a plus 2b minus a plus 2b. Aunt Sally says make sure you always simplify your parentheses or grouping symbols first, so I'm going to combine my a's. 6a minus 1a is 5a. 2b and 2b is 4b. Lastly, we can distribute that negative 3 to get negative 15a minus 12b. Make sure you distribute that negative. Okay. last side here, some try it on your own now that we've run through some examples. Hopefully these are not too difficult for you. Your homework for the next class will be to complete the 1.6, 1.7, and 1.9 My Math Lab assignment. Also make sure you complete the 1.4 and 1.5 ICA, which is found in Week 2 folder on Moodle.